All right, we're going to see how to take the derivative of some basic log equations. You'll remember that I taught you that if we have y equals the natural log of x, then that means that dy dx is equal to 1 over x. So that works great for the natural log. However, it's a little bit different if we're doing a log with a base. In that case, the derivative of a log with some base b, if we're finding the derivative of this thing, that will equal 1 over, and what it ends up equaling is the natural log of the base times x. All right, so those are your two equations. If it's log base b of x, it's 1 over ln of b times x. So let's use that idea with this one. If y equals log base 9 of x, the derivative of this is simply 1 over the natural log of 9 times x. Okay? And notice, by the way, that if your base is e, this works out because it's the natural log of e, which becomes 1. So then you just end up with 1 over x. So that's all that's happening. It's 1 over the thing, natural log of your base times x. Let's do another example. Y equals log base 7 x to the 8 plus x. Derivative of the outside for the chain rule is going to be 1 over the natural log of 7 times x to the 8 plus x. So that's from the derivative of the outside. You do 1 over and then all the stuff, but we need that natural log of 7 here because we have a base that's not e. Now we need to do the chain rule, so you multiply by the derivative of the inside function, which is going to be 8x to the 7 plus 1, because the derivative of x to the 8 is 8x to the 7, derivative of x is 1. So I don't know if there's any simplifying we can do here, but that's the answer. The derivative of the outside was 1 over natural log of 7, and you also times that by what was inside your function, and then you multiply by this piece to get the chain rule. That concludes this section. Hopefully all that makes sense. If it does not, please send me an email. Other than that, we will do the next section, which looks at elasticity of demand.